Greetings folks and welcome to the Electromaker show. This is your midweek roundup of all things maker and embedded and lovely. Now this week we have a plethora of projects once again. Every now and again too many cool things land on my desk for me to do like a normal show. So this one is a bit more project, but there's still some funding website things, some kind of interesting news from the University of Arizona, a really interesting new industrial RP 2040 unit, and of course a mystery box contest. So with all of that to get through, let's get on with the show. Our first project this week is a guest post on the TensorFlow blog, which is Google's blog about machine learning. I'm sure you're familiar with TensorFlow. This is to do with TensorFlow Lite. This is a tinyML version which is targeting the RP 2040. Not only is it targeting the RP 2040, but it's using audio, and this is something that I, of course, as you well know, find very, very interesting. But this is less creating music and doing synthesizer-y stuff and more classifying audio coming in using a MEMS microphone. And it uses two variations of boards. One is the Sparkfun micro mod board that clicks together, but there is also a version that allows you to use a Raspberry Pi Pico along with a little MEMS microphone breakout from Adafruit. So this project is a step-by-step guide for how you can train and use a machine learning model using a pre-existing data set. Now, the data set is here on GitHub. All of these links, by the way, are taken from this main blog post. This is the one I will link. So this is a data set of 2,000 environmental audio recordings that were manually created, which must have taken some time. Everything from animals to natural soundscapes and water sounds, non-human speech sounds, interior domestic sounds, and urban exterior sounds too, like trains and things like that. And the idea is you take this data set and you train a model using it. It goes through a number of ways you can make this model better and work better. To me, TensorFlow and machine learning, there's still a little bit of the black box to it, the magical box where you do what it says, you give it what it wants, and it gives you back something. And I still don't fully understand how it works. As I said, I got as far as making a toy neural network back in the day, and I've worked with TensorFlow to write tutorials on it. I do not pretend to understand it at this stage. But there's things like augmenting the data by adding white noise and random silence to the audio to make it better at classifying different sounds that aren't the exact models that you're trained on. So yeah, as you can see, this is a fully featured tutorial telling you how to do it all. It also tells you how to set up the hardware. If you have the micro mod, obviously it's a lot easier. You can just plug it all together and go. But the Pi Pico isn't particularly difficult either. It's just learning to wire it up using a breadboard. Yeah, it's just a really well-written tutorial, as you would expect if it's something that ended up on the TensorFlow blog. So I will leave a link to this post in the description of the video, and from here it links out to the GitHub page if you want to just get the files and do it on your computer locally with your own IDE. But there's also a Google Collab, again linked in the original blog post, which is an interactive version of the tutorial. And if you are using, say, Google Chrome or whatever, a web API based browser, you will be able to upload the code directly from the browser to your hardware, to your Pico or your Sparkfun RP 2040 board, without having to download anything at all, which I think is quite a nice touch. Now, on last week's video, I showed you the Udo Key. This is the board that mixes an ESP32 and a Raspberry Pi Pico. And I said like many other people, find ESP32s and RP2040s mixing on the same board to be a little bit weird, given how powerful the ESP32 is. And someone in the comments pointed out something that I had completely forgotten. So Tim Ballum mentioned the reason for the RP2040 is the programmable I/O. I had completely forgotten about PIO, which is strange considering I was talking about how interesting I found that when the board originally landed, and we've featured PIO tutorials on the show before. And he linked a video that sent me down a very happy rabbit hole. And this is the video that was linked. This is James Lewis, otherwise known as Bald Engineer, on Element 14. And this is a video where he is trying to emulate the EEPROM of an Apple IIe, or a mini Apple IIe, or Apple IIe Mini. I can't remember the exact title of it. And this particular video is a discovery video where he tries an Arduino Mega and a TNC4, and then settles finally on the Raspberry Pi Pico, the RP2040, because of its PIO. Now, in order to get the keyboard talking to the rest of the computer, it takes very, very specific timing, obviously. I mean, timing is everything when it comes to communication digitally. This video is essentially an explainer of how it works and why different microcontrollers maybe did not work all that well. It is a fascinating video, and it gives you a very nice idea both how older systems worked in terms of getting input from the keyboard, because what he essentially is trying to do here is completely replace the system for getting key strikes in so that you could make a USB keyboard input for an old Apple II Mini, if I'm understanding right, which is a fantastic project. It's really cool. And this video explains the theory on that side of it. but doesn't go into the PIO. It is something that he says he may cover in the future, but this sent me down the rabbit hole of learning about PIO again, because the programmable inputs and outputs on the RP2040 are something really quite special. So my PIO rabbit hole took me back to something we've actually featured on the show once before. I featured part 3 of this tutorial on the show quite some time back because it uses the PIO in order to create audio, which is obviously very much up my street. If I remember correctly, the original part 3 was how to make a square wave synthesizer using PIO. But I went back to this tutorial and went back to the beginning just to sort of give myself a refresher on how PIO works. If you aren't familiar, I will try and say it in a single sentence and probably butcher it, but that is that PIO are programmable state machines that have their own processing power separate from the main block of the processor. So when you send it to do things, it does it completely independently of the CPU. You send it its own version of assembly instructions and it will do that task at the speed that you say it should without bothering your general programming routine. If you are a programmer and I've horrifically butchered that, tell me why I'm wrong in the comment section below. So this very simple getting started guide with PIO uses MicroPython, and it shows you how you can do certain things using PIO without having to bother your main processor. This essentially is just using 2 of the little state machines to turn the LED, the onboard LED, on or off. One of them turns it on, one of them turns it off. But the frequency with which they do it is slightly offset so that you get a fading effect, which is a nice thing to do, but your LED can fade in and out and it doesn't touch your main processing step. You can just set it and forget it and it'll work. A really wonderful idea. So that was the MicroPython version, and it is incredibly easy to get the PIO up and running with MicroPython. Incidentally, CircuitPython is also PIO ready, and it's equally easy to use. They do it slightly differently. It's done as a string. I haven't really messed around with it all that much. I just sort of looked at it, but there's a few tutorials out there if you're a CircuitPython user as well. However, I suspect a lot of you are C/C++ users, and this guide from Sean Heimel, who's a fantastic maker of videos and tutorials for all kinds of microcontrollers. I know several people had their first experiences with the STM32 from Sean Heimel's video on the subject, but this is his guide for using the C and C++ SDK in general with the RP2040. Part 3 is how to use PIO. And the example is relatively simple. It tells you how it all works, and there's a nice example here, a nice diagram here of how it all fits together. And as I say, core 0, core 1, and PIO 0 and PIO 1, separate things. They do their own thing. And then there is some program code. So you make your own, in the C version of the code, it's a little bit different. You make a separate file, which is blink.pio, and this is all of the code that takes care of that. And then, of course, you make a main.c file, and you have a CMake file, and you need to change that in order to make this work. You need to tell it to use the right parts of the PIO from the SDK, if I remember correctly. I did read through this, but it was a couple of days ago. And yes, this is just a really good guide for getting started with PIO. If you want to know more about the actual PIO itself, of course, the Raspberry Pi datasheet tells you exactly how the entire thing works. The Raspberry Pi Pico datasheet is probably still one of the best I've read recently. It has an incredible wealth of information on the SDK. I wish I had a bit more time to really dive in and mess around with the Pi Pico. But I can't believe I'd forgotten about the RP2040's PIO. Thank you so much for reminding me. I hope one of these things I've showed you now is useful for your tinkering. Oh, and they will of course all be linked in the description of this video. So yes, Novaspirit Tech's Pi hosted series. This is using a Raspberry Pi 4 as a home server, and the very first video is installing the essentials like Docker, Portainer, and Shell in a box. The actual base operating system, by the way, is just the Raspberry Pi Lite. It's the server edition of Pi Lite. And as this video reminded me, something I haven't actually done in a while, when you make an SD card for a Raspberry Pi server, oh my, it's quick. It's just so little operating system goes on the SD card, and I'd completely forgotten about that. So I haven't got all that much more to say about it other than that this is a fantastic series if you want to set up a modern Raspberry Pi server with a lot of modern tools, some of which I am familiar with, some of which I'm not. So as mentioned, this starts with Docker, it starts with Portainer, but there's a few other things like the Homer dashboard, something I am not familiar with at all. Guacamole, I know, that's Apache's thing, I think. JDownloader, and there's making a file browser on the Pi Docker server, a whole bunch of different things, all of which are things you may want to have on a server. And this is an ongoing series. He's going to keep updating it until he's basically happy and finished with this one server that can do it all with a beautiful dashboard and a bunch of things that it is capable of doing, all on a tiny little form factor Raspberry Pi 4 computer. A great series, and as always, I would feature a lot more Novaspirit Tech stuff on the show if I had the time to, because Don's just a fantastic presenter, always comes up with super interesting Raspberry Pi projects. Up next, an article on Tom's Hardware that really caught my eye. Now, this is a Raspberry Pi CM4 compute module used in a custom Nintendo Switch Lite replica. And it took me a while to get my head around that. When it says replica, this really is a replica. I thought they'd ripped apart a Nintendo Switch and somehow stuffed a compute module inside it to make a retro gaming handheld, because it runs RetroPie. It runs your usual thing. But when you actually take a look at this image, look, this is a custom case. This is a completely custom build. It's just based around the Switch Lite's design, which is incredible. So the original Tom's Hardware article I found I will link because it's a great read and it gives you a rundown on what the project is. But you can also find linked in that article a link to the original post here, which is basically saying, hey, this is the start of the project. This is October 28th, 2020, saying, look, here's the plan. We're going to use a compute module 4 to make a kind of thing like this. I love the fact that in this post they say they don't have any experience or much experience with Raspberry Pis, haven't read the datasheet, but can do a bit of C programming. And doing quite a lot of projects with PIC 8-bit microcontrollers. And then you fast forward to 4 days ago and look, 95% over the line, and look how wonderful this thing looks. Now, if you want to know more about this project, you can, of course, follow Stoned Edged on Reddit. You can follow users on Reddit if you weren't familiar with that. Or you can bookmark this thread in the Raspberry Pi forum. If you come down to the end of it, you'll notice that they're still actively talking about it. I mean, this is July 2021, and this is August 2021. I imagine as they keep working on it, they will come back and talk about some other things. This being a compute module floor, it will be able to run things pretty decently. There's actually a comment here saying what will run and what won't. Anything up to Dreamcast and PSP at full speed. Anything higher, like GameCube and Wii, you'll have to wait for a later Pi or use something like Moonlight, I would guess, to stream from a PC. They are planning on making a kit form of it eventually and are probably going to open source it once all is said and done. But for now, it's just a wonderful looking project and a really nice idea. Now, I realize that without meaning to, every project we've had on the show so far this week has been a Raspberry Pi or Raspberry Pi Pico or RP2040 project or tutorial or whatever. So let's remedy that with some good old Arduino action. So dial A for Arduino, this is from the Hackaday blog, and this uses an old rotary phone encoder, or a dial I think you probably would call it, in order to send signals to the Arduino, and the Arduino then tells what those signals are, and in this instance switches between two LEDs, but you could use it for, well, pretty much anything, I should think. So this Hackaday blog links out to this Instructables, and there is a video here as well, which is definitely worth a watch that explains it all very well. Something about these old telephone dials that I think is really interesting is that they're not dissimilar in a way to peripherals talking to microcontrollers, because these things, when you would turn it round, if you turned it to say the number 6, it would come back and give you 6 clicks. And there was a certain amount of pulses per second that would be understood by the operator's end, I believe. I've read a little bit about this since the project has been open, but yeah, it's obviously it's much slower than an Arduino can read, so an Arduino is perfect for doing this. And it's just such a nice way of using an old bit of kit. My immediate thought of this would be, why not use the whole telephone? Why not turn it into something to, I don't know, the slowest synthesizer in the world? You dial 5 and then it plays the 5th note in a scale? I have no idea. You know, through the earpiece? Spitballing, no idea if that's a thing that can happen. Maybe I need to get an old phone and try. Another nice thing about this tutorial is that, as well as learning about the old rotary dials, you'll learn a lot about the Arduino's chip, the ATmega328P, because to use it with proper timing, you're going to want to actually speak to it in a language it truly understands without the Arduino abstraction, and that's what all of this McGubbins here is. This is setting registers directly and shifting bits in and out of it. Something you've probably come across, especially if you've followed the tutorial series that Mitch Davis put out, the one that I talked about extensively on this show, about how to go from Blink on the Arduino IDE, the nice and simple way, right through to doing it completely bare metal. Yeah, this is a great tutorial to follow to learn a lot about that Arduino Uno that you already have, and of course how the old rotary systems worked as well. Really nice project. So the Instructable is by Jake of All Trades, so maybe if you just want to search rotary dial Arduino input Instructables, you'll get it that way, or of course you can head to the link in the description and head straight to the Hackaday blog and follow this link here. Oh, it is nice to have a big box full of mystery prizes to give away. Look, it even says mystery on it, and it's given to us by the wonderful people at Mouser Electronics, as you can see. So let's waste no time. Let's get our hand in there and pull out a box. On semiconductor. Oh, that's fancy. This is a tiny little evaluation board, which takes a coin cell battery and has at least a microcontroller and a couple of user switches and what looks like some sensors on board. Let's see if there's any fun documentation. Oh, what's this? Oh, and so there's the battery for the coin cell and what looks like an NFC antenna. So this is an NFC device. Is this like a little Bluetooth low energy board? I should probably stop guessing and just look it up. Oh, okay, this is something quite special. The RSL10 Sense GEVK. It's an evaluation kit for the RSL10, which is a little system in package, which has a system in chip and an aerial, works with NFC, Bluetooth Low Energy, and mesh. Now, this has a bunch of little sensors on it as well. It has environmental sensors, a 3-axis accelerometer and gyroscope, and a low-power smart hub for motion sensing. Not sure what that is, but yes, this is a really feature-packed little board. So yes, here are the features. Bluetooth 5 certified system and package. It has an ambient light sensor, the low-powered smart hub, which is that motion tracking thing that I'm not familiar with, an accelerometer gyroscope, a geomagnetic sensor, and a high accuracy gas pressure, humidity, and temperature sensor, a digital microphone, a programmable RGB LED, and 3 programmable push buttons, along with an NFC controller as well. Just a bunch of stuff. There's also an app here that I noticed. Yes, there is a RSL Sense control and mobile app for cloud connectivity as well. This is a really powerful little development board. It's a really lovely little thing, and it is really tiny as well. Look, just a tiny little thing. You can probably hardly see it because I'm small on the screen, and it is small too. So this is definitely one of the cooler prizes we've gone out in quite a while. On Semiconductor always make really nice stuff, but I wasn't familiar with this board. I'd heard of the chip before, probably from reading CNX software. That's the kind of place I read that stuff. But anyway, this is Waffle. We have a prize. Let's give it away. And the winner of the mystery box competition is Not Enough Tech, who was actually quite kindly saying congratulations to the winner of the last competition, which was the My Cobot Pi competition. Yes, Not Enough Tech is a great friend of the show, although the mystery box prize winners are picked at random. There is no weirdness going on here. So congratulations. We'll be in touch with you as how we can get this beautiful little evaluation board that I'm not holding in my hand anymore. I just don't know why I did that. We'll be getting that out to you soon. So the mystery box competition will return along with some bigger competitions like we've started doing from time to time. But for now, let's get on with the rest of the show. Before we move on, a little quick housekeeping. So if you are enjoying the Electromaker show, it would be a great help if you could subscribe to the channel. You can do that on the main page here, or you can of course go to any video you are currently watching, like this one for example, and just scroll down and click the subscribe button here. Next to it is the notification button, and as far as I can tell, personalized notifications don't really do anything. At least I haven't noticed it in my experience, but clicking all means that you will get a notification here in the browser when you are only on the YouTube website saying, hey, there's a new Electromaker show. You should only get notifications when you come to YouTube unless you've said allowed your browser to give you notifications from YouTube on the desktop, which is something I wouldn't recommend doing anyway. Letting your browser give you desktop notifications can be quite annoying. Now, of course, clicking like is also always appreciated because that really does let us know that you like the show, but it also lets YouTube know that you like the show, and they're much more likely to show it to other people who watch shows to do with the kind of thing that we talk about, which will, of course, help us greatly. All of these things are free to do, and if you are a person with a YouTube account, I'd appreciate it if you did it. There are, of course, other ways you can support the show, however. So on the Electromaker website, under the Community tab, you will see there is a Projects tab that you may already be familiar with. In fact, we feature things from the Projects tab on the show relatively often. And you can see these are projects from Electromaker community members, some of which are tutorials and some of which are just simply showing off things that they have made. If you would like to do that, under the Community tab, you can click Upload Project and make a free account with us, which will allow you to upload your project. And again, as I say, I frequently check that tab for things to put in the show. So if you have made something or are even working on something or just want to explain something, a concept that you have learned yourself recently, it's a good place to do that. You can also join our Discord server from here. If you're not familiar with Discord, it is an online chatting platform. It is both text and voice oriented. So even if you want someone who particularly wants to chat in voice comms, you can just use text. In fact, our Discord server is purely a text-based Discord server at this point. At some point in the future, I'll probably put a voice channel in there and do some little live streams just for people on the Discord server. But as it stands right now, you can just get in there and chat about projects or chat about the Electromaker show, give us suggestions, and drop things in that you think might work for the show. But by far the best way you can support this show is by buying things from the Electromaker shop. We stock a bunch of stuff, as you can see from all of these people scrolling over the top right now. Everything from Arduino to BeagleBoard to C to Pimoroni, Raspberry Pi, Tiny Circuits, who made the wonderful little thummy device on last week's show. Yes, as you can see, a lot of folks. So if you want to support us directly, this is by far the best way you can do it for your next project. Get your stuff from us. There's absolutely no obligation, however. This is a free YouTube show, and any kind of support you can show us is always appreciated. Anyway, I think that is it for housekeeping for this week. Let's get back to the show. Now, in a show so crammed full of projects, we don't really have that much time for other stuff, but we are going to do a very quick funding website things, heading over to CrowdSupply to look at a very cool new smart display. So, Newt, a low-power, open-source 2.7-inch IoT display powered by an ESP32 S2 module and featuring Sharp's memory in pixel screen technology. And you can see it right here. Now, these are all lovely little capacitive touch buttons. There are 10 of them in total, and on the back what you cannot see is, of course, the ESP32 S2. But what's really interesting here is the use of MIP technology. So MIP is something that I'm sort of vaguely familiar with. I've never programmed it, but it's something I know about because I've written about it in other jobs. And essentially, every single pixel on this screen has its own inbuilt byte. It has its own little 1-byte memory. That means that if you wanted to put this up on the screen, you could say, all of these pixels, you are on. All the rest of the pixels, you are off. And it will remember its state, and it will not need updating until you want it to change. They are 1-byte write only. Really cool idea. And yeah, this screen has it in the screen. In the screen? Yeah, of course it does. What I meant to say is this little smart screen has it built in. So in terms of features and specs, as I've mentioned, it has the ESP32 S2, and if you're familiar with that, you know that is a super powerful little microcontroller for doing a bunch of stuff. That works with the Arduino IDE, it works with CircuitPython, MicroPython, a bunch of different things. And it is also able to be updated over the air as well, which is something that we talked about on the show in the past. So this could just go up on your wall and stay up there. And it is designed to be incredibly low power. So while it's hard to know exactly how well it will stand up to constant use, yeah, it's designed, every single part is designed to be low power, as it says in the write-up here. It's 9 by 6 centimeters as well, which I think is quite a nice sort of medium range size for this kind of project. Anyway, as you can see, this has not gone live yet, but you can enter your name here if you want to be told when it does go live. And again, there's no information as to how much this will cost when it does go live yet, so this is one of the ones we'll probably come back to and visit again on another show. We're going to close out this week's show with a new product and a piece of news, starting with Iono RP. This is a new product featuring the RP2040, but it is an industrial programmable logic controller. Now, I am 100% aware that PLCs aren't necessarily something that excites some of you. However, for some of you, the idea of an industrial level programmable logic controller with an RP2040 and it might be just what you like to hear about. Either way, this is being reported on by the wonderful CNX software, and it is what it says. An industrial PLC with an RP2040 at its core, and it offers a bunch of interesting stuff. So it is, of course, DIN rail mountable, and it has digital and analog inputs and output lines, along with power relays and an RS485 interface for chatting to it over serial, and a variable voltage input from 12 to 24 volts. So again, it's your standard industrial fare. You can plonk it anywhere, use it for almost anything, talk to it over serial. Bear in mind this is an RP2040, so it is not Wi-Fi or Bluetooth by nature. You would have to add that yourself, but then again, a lot of this stuff doesn't work that way. There's a reason why the RS485 is such a well-known interface. Now, if you do want to know the full specifications, they are listed here, and there is also a block diagram of how it all works as well. Worth noting, there are various versions of this. There is the base version, and as you can see, there's a couple of spots on the board here for other stuff. This is for adding a real-time clock if you want to have a real-time clock. You can also have a secure unit. Again, this is a part of microcontrollers that I have not put much time into reading about. I'm aware that it is something that is important, and it is being put into many microcontrollers as standard now, having a separate secure unit on or off chip. And then you can also have an earthquake sensor, I believe, was the other thing. So if I remember correctly, the version with the earthquake sensor, it does not seem possible to order a model with the earthquake sensor, at least not through the online store. But if you would like to have a look at this, you can head to the link in the article that I will link in the description, and you can see they start at €189 for the base version. We're going to close out the show with the news that engineers from the University of Arizona have developed a 3D printed sensor that can fit on your arm and never needs charging. Now, this is interesting for a number of reasons. The fact that it's 3D printable is fantastic because it's easy to manufacture, and it means you can fit it directly and perfectly to the patient. Now, this turns out to be quite important because really well-fitted sensors that are personalized to a patient means you can get really accurate readings. It says a little bit further down in this article that they managed to track the difference in temperature change from walking up a set of stairs. That slight difference in temperature change it takes for someone who goes through the effort of walking up the stairs, they were able to sense it. And it is completely wireless because it uses wireless power. Now, whether this is a similar kind of wireless power that you get when you put a mobile phone on a wireless charging pad is something I don't actually know. I don't know a huge amount about wireless power in general. There is a fantastic Great Scott video about it on his YouTube channel where he talks about wireless power and how far he can fire the power. In this particular instance, whoever's wearing these sensors need to be standing somewhere near a wireless power generator with a range of a few meters. And that is enough to give power to the little Bluetooth module, the little microcontroller, and the little sensor on their skin. Another advantage of it being 3D printed is that it's very easy to replace, and it can be fitted to a specific body part. In fact, if you watch the video down here, they show that they not only do they have the thing itself. Oh yeah, so here's the thing: it's the integrated sensors and a Bluetooth-enabled module. There's probably a tiny little system in package with Bluetooth and microcontrolling. And here we are. This is the a mobile phone that allows you to scan someone's arm with a smartphone and then print a perfect fitting design. It's a really interesting thing. It's obviously this is research. It's right on the forefront now. This isn't something that's going to be appearing anytime that soon. But it is super interesting. And the fact that it is 3D printed means that, of course, if we did want to try and mess around and make something like this ourselves, we could, although I'm probably going to wait quite some time before trying to make any of my own sensing devices. Just because there's a high level of accuracy and research and time that goes into it, and I certainly don't have the latter. Anyway, I'll leave a link to this in the description of the video. It is a fascinating idea and a fascinating read. That has been our show for this week. Thank you so much for joining me, and thank you for all the support you are showing this show, both on YouTube or by buying stuff from the Electromaker store or by coming and hanging out in the Electromaker Discord server. I will be back for you next week, but for now, I hope you have a safe, fun, and creative week, and I'll see you in the next one.